At first glance, Mars seems like a place of stillness. Its vast, flat landscapes stretch endlessly in every direction, painted in muted tones of rust and ochre. From the safety of a rover's camera or a satellite image, the planet looks calm, silent. But stay long enough, and you'll see something rise on the horizon. A faint blur, a towering wall, a storm. Not just any storm. A planet-wide maelstrom of dust and wind, unlike anything Earth has ever known. Martian dust storms are among the most powerful natural phenomena in the solar system. They can span thousands of kilometers, cover entire hemispheres, and last for weeks or even months. These storms are not just meteorological curiosities. They are serious threats to exploration, equipment, and the safety of future colonists. So what causes these massive storms? It begins with sunlight. Even though Mars receives only about half as much solar energy as Earth, it's enough to heat the planet's surface, especially during the southern hemisphere's summer. As the air warms, it begins to rise, creating turbulence. Winds sweep across the dry surface, picking up fine particles of dust no larger than talcum powder. Once airborne, the dust absorbs more sunlight, heating the atmosphere and creating more wind, a runaway feedback loop. Unlike storms on Earth, which are often driven by moisture and condensation, Martian storms are entirely dry. There's no lightning, no thunder, no rain, just dust. And that dust is incredibly persistent. It clings to solar panels, obscures the sky, and fills the thin atmosphere with a reddish haze. Some storms remain localized, small tempests that kick up dust over a valley or crater. Others grow rapidly, spiraling into planet-encircling storms that block sunlight for weeks at a time. During these events, the sun can vanish from the Martian sky, reducing visibility to near zero. For solar-powered missions, this is a death sentence. In 2018, NASA's Opportunity rover, after nearly 15 years of service, succumbed to one such global dust storm. Its solar panels, coated with fine Martian dust, could no longer generate enough power to maintain communication. Engineers tried for months to revive it, but the silence remained. Opportunity was lost, not to age or failure, but to dust. Future colonies will need to account for this ever-present threat. Power systems must be diversified, relying not just on solar, but also on nuclear or fuel cell technologies. Habitats will require airtight seals and air filtration systems to keep dust out of vital systems and human lungs. Because Martian dust isn't just inconvenient, it can be hazardous. The dust contains perchlorates, toxic compounds that pose risks to both equipment and health. Inhaled in large quantities, they could cause respiratory issues, thyroid problems, or worse. That's why advanced airlocks, decontamination chambers, and vacuum suits will be essential tools for Martian explorers. There's also the challenge of visibility and mobility. During major storms, visibility can drop to just a few meters. Rovers may be unable to navigate. Drones could be grounded. Even walking between habitats could become dangerous. Communication systems may also be impacted. While Martian storms don't carry as much electrical activity as Earth's, the sheer scale of airborne dust can interfere with radio signals, satellite uplinks, and surface relays. But it's not all doom and gloom. Understanding these storms is also unlocking fascinating insights about Martian climate, history, and atmosphere. Scientists have discovered that dust storms may play a key role in transporting water vapor and other molecules across the planet. They may also contribute to atmospheric loss, helping explain why Mars lost its once thick atmosphere billions of years ago. Advanced weather monitoring systems, satellites, orbital sensors, and AI-powered simulations are helping researchers predict storm behavior with increasing accuracy. Colonists will likely receive early warnings of approaching dust walls, giving them time to shelter, switch power modes, and seal off critical systems. At infinity beyond, we see Martian dust storms not just as a danger, but as a reminder. A reminder that even a quiet world holds power, that a planet can whisper, then roar, that survival on Mars will require respect, preparedness, and above all, adaptation. Future missions may learn to live with the storms. Habitats could be built underground or shielded with regolith. Solar panels may rotate or fold into protective housings. Air filtration systems will mimic those used in clean rooms or lunar bases. Some scientists are even experimenting with electrostatic repulsion, where surfaces repel dust using charged fields. Others envision self-cleaning robots that roam the colony, sweeping or blowing dust off critical systems. And perhaps one day, we'll learn to harness the storms themselves. Just as we've learned to harness wind and solar energy on Earth, future Martians may find ways to convert turbulent winds into power. Bladed turbines, flexible piezoelectric sheets, or dust motion converters could turn chaos into electricity. Where there's danger, there's also opportunity. The red planet will never be gentle. It's a world shaped by extremes of cold, radiation, and dust. But with every challenge it throws at us, Mars teaches us something new about science, about survival, and about the unbreakable will of those who dare to reach for another world.